What is hydrogen embrittlement in metals? Imagine a tiny invisible force quietly weakening the strongest metals until they suddenly crack or break. That's what hydrogen embrittlement does. It's a sneaky process that can cause unexpected failures in metal parts. Hydrogen embrittlement happens when hydrogen atoms get into the metal's structure. Metals like high-strength steels are especially vulnerable because their crystal structures allow hydrogen to move easily inside. When hydrogen enters, it tends to gather along grain boundaries and tiny defects in the metal. These are areas where the metal's structure isn't perfectly uniform. Once inside, hydrogen atoms interfere with the metallic bonds that hold the metal together. This creates internal stresses and weakens the metal's ability to stretch or bend without breaking. Over time, microscopic cracks form and grow, especially if the metal is under stress from forces like tension or pressure. These cracks can suddenly cause the metal to fracture, often without warning. Hydrogen can enter metals from many sources. During manufacturing, processes like welding, electroplating, or acid cleaning produce hydrogen chemically or electrochemically. Metals exposed to hydrogen gas environments, such as pipelines or pressure vessels, can also absorb hydrogen. Corrosion and cathodic protection systems, which are used to prevent rust, sometimes generate atomic hydrogen that gets into the metal. There are two main types of hydrogen embrittlement. Internal hydrogen embrittlement occurs when hydrogen is trapped inside the metal during production. Hydrogen environment embrittlement happens when hydrogen from the surrounding environment gets absorbed during service. Both types can cause the same problem, making the metal brittle and prone to cracking. The process involves 3 steps. First, hydrogen gets into the metal from external sources. Next, it diffuses through the metal, concentrating in areas of high stress. Finally, cracks start to form and grow, leading to sudden failure. This is why it's so dangerous in critical applications like aircraft parts, bridges, or pipelines. Preventing hydrogen embrittlement involves controlling hydrogen exposure during manufacturing and use. Baking the metal at high temperatures can help remove trapped hydrogen. Choosing materials less prone to embrittlement, like certain alloys, is also effective. Making surfaces smooth and free of defects reduces places where hydrogen can gather. Understanding hydrogen embrittlement is key to avoiding unexpected failures. It explains why some metal parts break prematurely even when they seem strong and sound. By managing hydrogen exposure and selecting the right materials, engineers can keep metals safe and reliable in many applications.